Alright, now I'm going to teach you how to write formulas for ionic compounds. So first you need to remember that ionic compounds have to be neutral. That means if one side is positive 3, the other side has to be negative 3. So when you write formulas, you're going to take the name and convert the name into its symbol form. You're also going to write the charge next to it, and you'll do that for both the cation and the anion. And this says if more than one is needed, you'll add a subscript to one or both of them. So what I'm going to teach you now is what's referred to as the crisscross method. And I'm going to switch over to my document camera for that. Alright, so for the crisscross method, I'm going to give you two examples of how you do this. Calcium, I'm going to write the symbol and the charge for calcium. Remember, calcium's in group 2, so it's +2. Chlorate is on your polyatomic ion sheet. So if you look on here with me, chlorate is ClO3 -1. And like I said, since these charges are not the same, we have to do something about that. We want the charges to equal out. We want them to be electrically neutral. So to make this stable, what we're going to do is cross over this 2 and add parentheses around chlorate. So notice we're putting the 2 on the outside of the parentheses. Now together, this gives chlorate a -2 charge. It would be like saying if calcium wanted to bond with chlorate, you would need 2 chlorate ions in order to balance out that charge. So we're just putting a subscript of 2 next to chlorate to show that 2 of them have to bond with calcium. So the final formula would just be Ca parentheses ClO3 close the parentheses 2. For our second example, you've got iron 3 oxide. So we've got iron, Fe. That Roman numeral means that the charge is +3. Oxygen's charge is -2 because it's in group 6. So I cross the 2, I cross the 3. That makes the charges +6 and -6. So the final formula would be Fe2O3. So again, showing you the actual numbers of elements, if you had 2 irons with a +3 charge, you'd have to have 3 oxygens with a -2 charge to balance that out. So now it's +6, -6. So that's what those subscripts mean. Now the first worksheet that you've been working on for this section of our unit, on the front of it you're supposed to name ionic compounds, and on the back of it you're going to be applying the crisscross method to write formulas. So I just wanted to do a couple examples of both sides of this sheet with you just to get you started. We'll start with the back. We'll start with the crisscross method since that's what I just taught you how to do. And I want to do an example further down the page. So we'll do the iron with a +3 charge. So the way you're going to fill this out is you're going to put iron with a +3 charge all the way across in every single box on that row. And then you're going to take whatever anion is in this first column and bring that down. Cl -1, CO3 -2, OH -1, SO4 -2, PO4 -3, and then NO3 -1. So for this first one, since we have a 3 and a 1, we need to cross those. So cross my 1, cross my 3. And you never see a 1 in a formula. 1s are always understood. So the actual formula is going to be FeCl3. For this next one, I have 2 different numbers. So I'm going to cross my 2, put parentheses around CO3, and then cross my 3. So that final formula would be Fe 2, CO3, 3. For our next one, I cross my 1, cross my 3, add parentheses, and remember that 1 is just understood, so it would just be FeOH parentheses 3. For this next one, I have a 3 and a 2, so I'm going to cross my 2, add parentheses, and cross my 3. Notice that you only add parentheses when you're crossing a number onto a polyatomic ion. So this is Fe2, SO4, 3. And then for this second to last one, the charges are the same. It's plus 3 minus 3. So whenever it's the same, they cancel out. So you're not going to cross anything. You just write FePO4. And then lastly, cross my 1, parentheses, cross my 3. Once again, that 1 is understood. So it's just FeNO3, parentheses 3. So hopefully that makes sense. If it doesn't, please ask me questions. We're going to flip to the back now. I'm going to do a couple of examples from this side. Let's start with number 6. So for number 6, I have Fe, it's iron, and iron is one of your transition metals. It will need a Roman numeral. So to figure out the Roman numeral, I need to look at chlorine. I know that chlorine has a -1 charge, but since there are 3 chlorines, the overall charge is -3. So iron has to be +3. So this is iron 3. And then I change the ending of chlorine to chloride. All right, now I'm going to skip down to number 8. For number 8, you see that there are 4 nonmetals. That means there are 2 polyatomic ions. So if you look at your sheet, look for NH4, that's that first polyatomic ion. That is ammonium. And then NO3, that's the second polyatomic ion. NO3 is nitrate, right there. So the name of this would be ammonium nitrate. That's all you have to do. All right, skipping on down, let's look at number 10 now. So we've got copper, and then we've got this long polyatomic ion. I'm going to show you this one because there's 2 different ways you can write it. Either one is fine. I normally write it like this first option here, but this is acetate. And you'll notice that acetate has a -1 charge, and there's no parentheses, so that means we only have 1 acetate. So if it's -1, copper has to be +1. So this is going to be copper 1 acetate. And I'm going to do one more with you. I'm going to do number 13. You've got Ca, and then you've got C2O4. Well, I know that Ca is calcium. Calcium is in group 2, so it's always +2. I don't need a Roman numeral. C2O4 is on your polyatomic ion sheet. Let's see if we can find it. There it is. C2O4 is oxalate. Calcium oxalate. All right, you have the keys to the front and back of this sheet, so I would encourage you to try some on your own before you check your answers. And as always, please let me know if you need any help.